Okay, in this video, we're going to use the long division from the last video to try something to make our job a little bit easier than what we had been doing so far. Okay, so here's a polynomial. We're going to find the roots of it. X to the fourth plus x cubed minus 35x squared plus 101x minus 44. And we're told x plus 3i is one root, which, remember, means that x minus 3i is also a root. Now, we certainly could do the synthetic division to take out 3 plus root 2i and 3 minus root 2i and be left with a quadratic and solve that. We can. It'll work. But some of you might look at that and say, ooh, synthetic division with 3 plus root 2i, that's going to be a lot of multiplying imaginary numbers and getting a lot of a plus bi and adding it. Like, just sounds like a lot, and we'd have to do it twice for two synthetic divisions. So there is another option I want to show you. The other thing you can do is to take this x equals 3 plus root 2i and turn it into a quadratic factor. We know we can turn it into a linear factor just by moving that 3 minus, making x minus 3 minus root 2i. The other thing we can do is turn it back to a quadratic factor kind of by uncompleting the square. So bringing the 3 over, squaring both sides. Remember, because the square root of the negative 2 is why we would have gotten the I there. And then bringing the negative 2 over, which does mean I have to FOIL out the x minus 3 squared, but then I can bring the 2 over. And so, x squared minus 6x plus 11. The reason why you can do that, and once you get the hang of it, you can do it pretty fast, because once we're pretty comfortable with completing the square by now, so doing it in reverse is not so bad. The reason why we might want to do that is because now we can do division, long division, instead of synthetic division. And normally, we definitely prefer synthetic division to long division. But in this case, because the synthetic division would, first of all, we'd have to do it twice. Second of all, we'd be doing it with that kind of horrible a plus bi complex number. We might prefer to do it with long division. And we can use the divide, multiply, subtract pattern that we saw in the last video. It'll work here. So we can take x to the fourth over x squared. And remember, we only need to divide the first terms. That's why the division part is pretty easy. And then we can multiply x squared. I'm going to need a little bit more room here. We can divide multiply x squared times x squared minus 6x plus 11. It's just distributing. I know it's distributing to a trinomial, so there's a little bit more. But all the steps are the same. X to the fourth minus 6x cubed plus 11x squared. So then our next step is to subtract. And again, be careful with these double negatives. We saw this in the last example. X to the fourth minus x to the fourth canceled. X cubed minus negative 6x cubed is positive 7x cubed, because those negatives do cancel out. And negative 35x squared minus 11x squared is negative 46x squared. Divide, multiply, subtract, check, 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 start again. 7x cubed divided by x squared is 7x. Distribute that 7x back to the x squared minus 6x plus 11. 7x cubed, well, that's good, minus 42x squared plus 77. All right, seems like it's kind of a long number, but don't be scared off by that. 7x cubed minus 42x squared plus 77. Notice how I moved into my next term, which means I need to bring down that 101x here also, so I can do my subtracting. But we keep these columns all neat and orderly, So that way it's very easy to see that and to bring it down when we need it. Now we can subtract. 7x cubed minus 7x cubed cancels. Negative 46x squared minus negative 42x squared is negative 4x squared. And 101, sorry, I forgot my x here. 101x plus 77x is 24x. And I'm going to need that 44 in just a second. And we can see that the next step, the next division we're going to do, negative 4x squared divided by x squared is equal to negative 4, which is good because if we look at this, like hopefully you can see this without actually having to write it down, but doing the multiplication, all of the terms I'm going to get, negative 4 times 6x squared minus 6x plus 11, all of the terms are going to be exactly what I wanted them to be. Negative 4x squared, positive 24x, and negative 4 times 11 is negative 44. This is good because it had to work out this way because I knew that my remainder had to be 0. Had to be. So this is another way to get to the quadratic. X squared plus 7x minus 4. And if we want to find the zeros, we can solve that. This one doesn't factor. I could complete the square, but that would deal with fractions. So what I'm going to do is jump right into the quadratic formula. I'll do b squared minus 4ac. And then x is negative b plus or minus the square root of that discriminant all over 2a. And it's real, so I don't need to worry about turning it into a plus bi form. I can just write my solutions. 3 plus or minus root 2i, we knew that because they told us. And then negative 7 plus or minus root 33 over 2 is the other two roots that we found.